successful conventional landing in the AV8B. As you know, the Harrier is capable of landing in a number of different ways, and the conventional version is not the most common of these. In fact, a combination of design characteristics make conventional landings more of a contingency procedure, generally only used if there is a suspected failure of the reaction control system. The airplane was not intended to be routinely operated this way, and the poor ground stability characteristics of the AV8B make the CL a less than optimal choice under most conditions. We'll begin this lesson with an overhead brake. The overhead brake allows you to get an entire 4-ship division on the ground as quickly as possible, and therefore is the standard landing procedure for most naval fighter jets. You will have an opportunity to do it 3 times during this sortie. Remember, it takes time to learn how to do it properly. We are currently flying towards the Kapoleti Airport, which is waypoint 1, at an altitude of 15,000 feet MSL. Once ready, we will descend to the pattern altitude for the overhead brake, which is 800 feet AGL, perform a touch and go, and then repeat the whole procedure twice, with the third landing being a full stop. Let me know when you are ready to start with some basic information and restrictions. Okay, we'll start with the operating limits. The maximum landing weight for the Harrier is 26,000 pounds. It is very unlikely that you'll be fully loaded with fuel and weapons on landing apart from emergency procedures, and even these will require you to jettison your ordnance anyway. Maximum speed at which you can deploy your landing gear or fly with the landing gear down is 250 knots. The maximum speed on the ground is 180 knots, so you'll want to be slower than that during landing. Also, remember that the air brake is not available when the landing gear is down. Finally, a word on crosswinds. The Harrier does not tolerate strong crosswinds during landing, and strict rules are in place because of that. All the numbers I will give you are for the paved runways with a minimum width of 100 feet. If the runway is wet, deduct 5 knots from the figures. The limits are as follows. For the approach speed equal to or above 140 knots, the maximum crosswind is 20 knots during the day and 15 knots at night. For the approach speed below 140 knots, the maximum crosswind is 15 knots during the day and 10 knots at night. Additionally, if your gross weight is above 19,550 pounds, all the crosswind values I just gave you should be reduced by a further 10 knots. Of course, it is possible to land with stronger crosswinds, and it has been done before, notably by our forces operating in Afghanistan. Still, try to avoid it if possible. Now with all that out of the way, we are almost ready to begin our descent. Before we do, there is a short checklist that you need to go through. Ready? First, make sure that the stow stop is in clear position. Next, verify the weather information obtained via ATIS or from the tower. Pay special attention to the wind speed and direction, as well as the cloud ceiling and visibility. Taking all that into account, you will decide at this point on a suitable type of approach and landing. In this case, we already know that we will go for an overhead brake into a conventional landing. Next, prepare your instruments. Set your steer point to home plate, which is waypoint 1. Set up your take-hand. This will be covered in greater extent in the navigation training. Press the take-hand or TCN button on your UFC and use the keypad to enter the channel 6, 7. Press Enter, or ENT, when ready. Next, press push button 1 on the option display unit, or ODU, to select the TR, or transmit receive mode. Verify in the top left corner of your left MPCD that you see the bearing, distance, and time to selected take-in station. It should be showing around 068 degrees. Make sure that the waypoint text next to push button 11 is boxed. If it isn't, go ahead and press push button 11. We will now set the approach course for Copoletti, corresponding with the magnetic heading of the runway we are going to use. We will land on runway 07, and the correct value for it is 064. Turn the course select knob and watch the data in the bottom right corner of the MPCD change. In order to have a better view, press push button 20 to change the scale to 25. You should notice a line appear in the top part of that screen. This line is the course you will want to intercept. Turn toward it and fly straight until you are above it, then turn to heading 064. Performed correctly, both the bearing in the top right corner of the screen and the current heading in the middle of the screen should display the same value, and the line should be directly under your plane symbol. Configure your nav FLIR and HUD as desired depending on the time and weather. If the airport you are flying to is much higher than mean sea level, you may want to switch to radar altimeter display on your HUD. However, since Copoletti elevation is only 59 feet MSL, we will do that at a later stage. Check your fuel for any asymmetries. If these are greater than 300 pounds, balance both fuel tanks. Also, you may want to reset bingo bug to a brief setting, but we won't be touching it for now. As the temperature on the ground will be different than what you get at your standard cruising altitude, turn your cabin temperature controller knob to maximum in order to preheat the cockpit, and put the defog switch in the max position. During IMC landings and at night, at this stage you would turn on your APU. If your generator fails, the APU serves as a backup generator and would power essential systems. Obviously there is no need to do anything now, but we will be covering this in greater detail in the night systems lesson. Maximum speed at which you can deploy your landing gear or fly with the landing gear down is 250 knots. The maximum speed on the ground is 180 knots, so you'll want to be slower than that during landing. Also, remember that the air brake is not available when the landing gear is down. Okay, time to contact Kabaletti Tower. Set one of your radios to 133.0 and inform the airport that you are inbound. Note down the QFE altimeter value given to you by the controller. As you pass 5,000 feet MSL, set the QFE on the altimeter as instructed by Tower. Also, switch your nav and anti-collision lights to on and set your landing light to approach. While you descend, let's go through the game plan for the rest of the sortie. I'll do the overview now, as once you begin the break there won't be much time to go into detail. Ready? As has been mentioned before, we will perform an overhead brake. That means that you will arrive over the runway flying at 800 feet AGL and with a speed of 350 knots indicated airspeed. Once the end of the runway disappears from your view beneath the nose of the aircraft, you will make a 4G level turn to your right, reduce throttle to idle, and intercept 10 units AOA. You will hold that turn for 180 degrees until you are flying alongside of the runway but in the opposite direction, or 244 degrees magnetic. This part is called the downwind leg. You'll want to exit the turn at or below 250 knots and then descend to around 600 feet AGL. Once there, you will stay in level flight and perform the following landing checklist. Lower the landing gear, keep flaps in auto mode, check that the stow stop is clear and stowed aft, check for positive duct pressure, check that the brake pressure is 2700 psi with pedals depressed, and make sure that the water switch is set as required for landing performance. You will drive to between 1.3 to 1.5 abeam, which means around half the length of the runway beyond its starting point. Make sure that the nozzles are fully aft at 0 degrees and recheck that your flaps are in auto. Also, it is advised to switch to the radar altimeter at this point and enter the VSTOL HUD master mode. You should be slowed to 10 to 12 units of AOA at between 65 to 75% power. You will then turn towards the runway. For reference, use the 2 small lakes near the airport. You want to almost get to them. You will want to control the descent with your stick and the AOA with the throttle. Throughout the turn, you will be descending to an intercept approximately 500 feet AGL halfway through the turn at the 90 and 200 feet AGL when you roll out on final in the groove. Try to keep AOA between 10 and 12 units and keep the speed below 180 knots. Don't go too slow. If you do, your AOA will get high. Finding the sweet spot here is the tricky part. At around 50 feet AGL, place the witch's hat at 2 degrees above the horizon. Continue to control your rate of descent with the throttle and attitude with the stick, and maintain 12 units of AOA. On a full stop landing, at touchdown you would set the throttle to idle and make sure that you're rolling straight with the pedals neutralized before engaging nose wheel steering. You would then set the nozzles for power nozzle braking, or P&B, trim for 2 degrees nose down, and set the throttle to 70%. However, as this will be a touch-and-go landing, immediately after touchdown, I want you to increase the throttle to full and allow the aircraft to take off again. That's about it. I will now let you focus on your approach. Make sure to align your aircraft with the course line, arrive over the runway at 800 feet and 350 knots, and fly straight until I tell you to turn. I will then be giving you abbreviated instructions.
Kapoleti, Dodge 1, inbound. Kapoleti, Dodge 1, inbound. Kapoleti, Dodge 1, inbound.
Well done, you are within the approach parameters. Alright, 4G right turn, reduce throttle, intercept, and keep 10 units. Level off when running parallel to the runway. Good, descend to 600 feet, stay below 250 knots indicated, fly straight. Landing checklist, gear down, flaps auto, duct and brake pressure checks good, water not required, nozzles aft, warning and caution lights are out. Also set the master mode to VSTOL and switch to radar altimeter.
Caution, caution. Caution, caution. Caution, caution. Altitude, altitude. Caution, caution. Caution, caution.